Hello, my name is Marco Arruda, and that's the second part of the tutorial exploring ROS with a two-wheeled robot. So in this video, in the second part of the tutorial, we're going to work with macros inside URDF files, the files we're using to describe our robot models. Okay, so in order to keep going with this project, I'm gonna still using RDS, ROS Development Studio, provided by the Construct. So if you don't have an account yet, you can create one just going here through this button, sign up. As I have my account already, I'm just going to do the sign in. And here I have the list of projects. So if you are starting from the second part, it's okay, or maybe if you just forgot to save your project in the last video, you can just create a new project here. I'm gonna call it second part and put the same for the description, just to give an example. You can open the project here, and after having the project here working, so you have your workspace ready to be used, open a new terminal, come to this page here, bitbucket.org / the construct core two-wheeled robot. This is a public project, a public repository. You can just clone it. Okay, so use this link here. You can just come here to the simulation workspace inside the source folder, git clone, just paste using Ctrl+V, enter, and now you have the project in your workspace. Okay, so let's check it using the IDE. So here we have simulation workspace inside the source folder, this folder two-wheeled robot, which is actually not a package, but the package is inside it. So my two-wheeled robot description, that's our package. Okay, so if you are watching this video and you can see more than one commit here in the repository, you can come to this part of the tutorial just using this command here, git checkout, actually inside the folder two-wheeled robot, git checkout -b, the code of the commit and the name of the branch. So let's call it second part, actually -b, second part, and the code of the commit. Okay, so here we have a new branch, and you are using the same version as we are in this tutorial. Okay, so this video is about using XACRO files to organize your robot description. So here we have a very long file with many lines, and we want to have it more organized. Okay, so we are using this file in two launch files, RViz and spawn launch file, and actually we are just reading these files using the cat command here and filling the robot description parameter. Okay, so in order to work with XACRO and using the instructions of XACRO files, the macro instructions, we have not just to read the file, but generate a new file. Okay, so we have to use the command, we have to find the XACRO package and execute this script here, xacro.py. Okay, this way we are going to not just read the file, the XACRO file, but also we are going to execute this file, to execute all the instructions we can use of all the macro instructions we can use in URDF files. Okay, so let's start organizing this file. We have here many lines, in my opinion, so we can just separate some code, put some code in different files. Okay, so let's start creating a new file here in the URDF folder. I'm gonna call it materials XACRO, and let's put these materials definitions here inside this file. So let's come here to the materials XACRO file. This is an XML file, so XML version equals to 1.0. Close the tag. Now we have to open robot tag. And inside the robot tag, just paste the content, the material definitions. Okay, this is an XML file. Let's define here. And in the XACRO file again, let's include it. So just use an instruction to include the other file instead of having all the content of the file. Again here, we can just include it. Okay, in order to do that, we have to use like this: XACRO include file name and close the tag. So my file, we can find the file inside the my two-wheeled robot description package /URDF /materials XACRO. Okay, so that's the path of the file. We are looking for this file using the instruction find. Okay, and we are going to read this file here. So let's check if everything is working properly. Okay, we have changed the RViz file. We are executing XACRO. Let's change also the spawn file. And now let's launch RViz. So ROS launch, my two-wheeled robot description, RViz launch. Graphical tools. Let's put it to the right side and make it bigger. Login. So here we have RViz. Let's add robot state. And we can check the robot. We have here the same model we have been working from the last tutorial. Okay, so everything is working as expected, but now we are using more than one XACRO file and we can have it organized. Okay, so we have also some gazebo tags here. We can also put these tags in a different file, so let's call it my two-wheeled robot.gazebo. Okay, and inside this file, actually let's cut the content of this file here and paste into the gazebo file. So the same here, XML, the version, open the robot tag, close it at the end of the file. Okay, so here we have another XACRO file and let's include it again. So here we have my two-wheeled robot.gazebo. And that's it. So let's make a test. We are including this file here instead of having the gazebo properties and tags inside the same file. So we are having a more organized file now. Let's test it. Let's run the simulation. Actually, an empty world. Let's put it to the right side. And in our terminal, let's close RViz. ROS launch, my two-wheeled robot, spawn.launch. Okay, so here we have the empty scenario. Let's spawn the robot, and we may have it here in a few seconds. So here we have the robot. Let's make sure everything's working as before. Let's try to send some velocity commands. In order to do that, let's use the ROS run tleop twist keyboard. That's the name of the package and the name of the executable. And now we must be able to send velocity commands to the robot. There it is. Great, so we have the same robot working, but now we are using a different way in our XACRO file. We are organizing this stuff in different files, in separated files. Okay. And one more thing I think it's really nice, it's very important to know about XACRO files, is that you can use macros. So not just including, separating instructions in different files, but also you can generate tags. For example, we have here right wheel and left wheel. We have two properties, they are almost the same property. We are just reflecting the position of the wheels, but actually not through the link, but through the joint. Okay, so we are reflecting this attribute here, x, y, and z of the joint, to have a wheel in the left or in the right side. So we are basically creating the same stuff twice. So how can we improve it? Actually, we can create a macro here, which is I believe it's the most important purpose of using macros in URDF. And let's try to make it. Let's see an example how we can do this. So I'm gonna create a new file here inside the URDF folder. I'm gonna call it macros.xacro. Okay, and let's start again with the same instruction, XML version 1.0. Open the robot tag and close it. And here we have to define a macro, the name of the macro. So I'm gonna call it, let's see, we have here link right wheel. So I'm gonna call it link wheel. And we have some parameters. So let's create what can we see here? We have difference between this link and this another one. So we have basically just the name of the link and the visual name. So we have link left wheel visual. So let's put here as a parameter name, the name of the link. Okay, and inside this macro tag we can just copy and paste what we are using here. Okay, and inside this name property we can just do like that, cipher, open and close curly braces, and here we can just type in the parameter name, which is name. Okay, for the visual we are going to use the same name, link right wheel or link left wheel underscore visual. So we just have to replace the part of the name. Okay, and the rest of the properties are the same. Great then. And here, how can we use this XACRO? Instead of creating the link, we are going to use like this, XACRO the name of the XACRO, which is link wheel. So XACRO link wheel, and the parameters we have. So name is equal to link right wheel. Okay, so basically that's it. Actually I have to close the tag here, and let's try to remove it, this link here, and also this one, link left wheel. But we have to change the name, right? Link left wheel and link right wheel. Okay. Before using the XACRO, you have to include the file, of course. So include inside my two-wheeled robot description URDF folder the name of the file, macros.xacro. Okay. Great then. Let's try to make it work. Let's restart the simulation. Wait a few seconds until the server is terminating the simulation and starting it again. here we have. Let's spawn the robot again. And we have the same robot with the same properties, the same wheels. And let's see if it's working as usual. So let's run ROS run, delay op twist keyboard, and send some commands to the robot. So great, it's working. And finally, let's create also another macro, but now for the joint. After all, we are doing almost the same for both joints we have in our robot. Okay, so let's create a new macro here. Macro name joint wheel, I'm gonna call it, and as parameters let's put like this. What do we have to change between this joint and this another one? So basically the name of the joint. So as a parameter, the name. Another parameter, the X, Y, and Z property we have also to change, okay, because we have different values. And let's see, the child link. So name, child, and the origin X, Y, and Z. So let's put like this: origin X, Y, and Z. This is how we are going to use this macro. So name here, the child goes here, origin X, Y, and Z goes here. Okay, so now let's use this macro here. Copy paste, instead of link wheel, we're going to use joint wheel. And as parameters we have name, child, and origin X, Y, and Z. So name, that's the name. The child is link right wheel, and origin X, Y, and Z, we're gonna use this value here. Okay, and for the left wheel, let's copy and paste. Joint left wheel, that's the child name, and the origin we are just reflecting this value. Okay, so we may be able to remove this joint because now we are using XACRO command. Let's remove it, and you see now we still have the link chases properties. This is important, and we are not repeating these instructions, so we cannot create a macro to reduce it. And this the macros for the wheels, left wheel and right wheel. Okay, let's try again to spawn the robot using the macros. Let's clear the terminal, wait for the simulation, a few seconds. And it's ready. Let's try to spawn a robot again. And there it is. Let's send some commands and see if everything is working as expected. Sending some commands and it works. Great. So basically that's it. This is how you can reduce your URDF file. This is a very good way. Actually, this is, I'm not saying this is the best way of doing it. You can do it by yourself if you think there's better way to reduce the file, or creating different macros to do it more efficient way. Okay, but that's the idea. Okay, now we are finishing the second part of this tutorial, this project. So before closing everything, I want to do a commit. Okay, So here I have my files. I'm gonna add everything because I want to commit everything. I'm gonna change to master branch, so git checkout branch. Okay, oops, git checkout branch. Here we have files, git commit, second part done. Okay, I have to configure my user, so user email. This is how you have to do it using RDS, so git config username, and here goes my name. Let's try to do the commit again, and there it is. Now git push, because I have rights to push to this repository. My password. And here we have the second part of the video committed and integrated to my repository. So if you like this kind of video, don't forget to subscribe to our channel and press the bell just beside the subscribe button to be notified about the videos we publish every day. Thank you.